All right, today we're diving into a research paper that could totally change how we think about building AI. It suggests there's a much smarter way to create intelligence, one that's all about cleverness, not just raw power.
So let me just kick things off with a big question. When it comes to making these incredibly powerful AIs, what if just throwing more resources at the problem, making them try harder, is actually the completely wrong way to go? Okay, let's start with the big problem. For all the amazing progress we've seen in AI, developers are really starting to hit a wall. And this wall, it's basically the law of diminishing returns in action.
You see, we're pouring an insane amount of money and GPU hours into training these gigantic models, but we're just not seeing those huge leaps in performance anymore. Especially when you ask them to do complex reasoning, they seem to be hitting a ceiling, a real performance plateau. We're putting more effort in, but we're not getting much more intelligence out. So what's causing this slowdown? Well, the research points to something really interesting. It turns out it's not about how much these models are practicing, but how they're practicing.
Okay, so the main villain here is something the researchers call sparse exploration. Just imagine an AI trying to solve a maze. Instead of trying out all the different routes, it just gets stuck going down the same few paths again and again and again. It develops this kind of tunnel vision, and it completely misses other way better solutions. And this right here really gets to the heart of the problem. The old way is all about scaling depth, just forcing the AI to take more steps down those same old paths. But the new way, the one this paper is all about, focuses on scaling breadth. It's about encouraging the AI to explore a much wider range of possibilities so it can find those truly brilliant solutions. And this is where our hero enters the scene, a brand new training framework called DeepSearch. And it's designed to teach AI how to explore that maze of possibilities in a much, much smarter way. I mean, the paper itself calls this a fundamental shift from scaling training depth to scaling training grit. So right there, it's not about making the AI train for longer. It's about making the training process itself smarter and way more expansive. So what's the secret sauce behind DeepSearch? Well, it uses a technique called Monte Carlo Tree Search, or MCTS. I want you to picture a grandmaster chess player, someone who can see dozens of moves ahead, weighing all the possibilities to find the absolute best path to victory. That's MCTS. And the real game changer here is that DeepSearch bakes this strategic thinking directly into the training process itself. So how in the world does DeepSearch actually teach an AI to think like a chess master? It's a really clever process. Let's break it down. It all happens in 4 key stages. First up, select. It looks at the whole problem from a bird's-eye view and picks out the most promising paths to check out. Then you've got expand. It starts generating new steps down those paths, kind of like a detective following up on different leads. Third, and this is crucial, learn. It gives credit where credit is due for good steps, but it also learns from its biggest blunders, the ones it was most confident about. And finally, adapt. It zeroes in on the toughest nuts to crack while reusing solutions it's already figured out. Super efficient. So what makes this whole thing so smart? Honestly, it's the difference between just rereading a textbook over and over and actually studying for a test. DeepSearch combines a few amazing ideas. It always keeps this big picture view of the problem, so no more tunnel vision. It's also designed to learn the most from its most confident mistakes. And it has a smart memory, so it doesn't waste precious time and energy resolving things it already knows. It's just focused, efficient learning. Okay, now for the payoff. All this clever stuff sounds great on paper, right? But does it actually work any better? Well, the data says a resounding yes. And frankly, the results are pretty stunning. First off, let's talk about efficiency. And this number is just, wow. DeepSearch gets its amazing results using 5.7 times fewer GPU hours than the old school method of just training longer. That's a massive, massive saving in both cost and energy. And it's not just faster, it's better. Take a look at this. On some really tough math reasoning tests, the DeepSearch model hit an average accuracy of almost 63%, beating the previous best model and setting a brand new state-of-the-art for models of this size. Now, to put that into perspective for you, that 1.25 percentage point jump might not sound like a lot, but trust me, in this world, that is a huge leap. It is solid proof that a smarter training method can absolutely smoke models trained with just brute force. So what does this all mean for the bigger picture? This isn't just about one model being a little bit better than another. No, this points to a fundamental change in the entire philosophy of how we build artificial intelligence. At its heart, what deep search really proves is the power of algorithmic elegance over brute force scaling. It shows that a smarter, more strategic way of teaching can be so much more effective than just throwing bigger and bigger hardware at the problem.
And the researchers themselves say it best. The future of reasoning model development lies in fundamentally rethinking how we structure the learning process. The next big breakthroughs, they're not just going to come from bigger models. They're going to come from better, more creative ways of teaching them. So look, if you take away just one thing from all this, let it be this. Deep search represents a huge shift in thinking. We're moving away from just making AI train harder and moving toward a future where we teach AI to learn smarter. And that really leaves us with this incredible, mind-bending question. If AI can learn how to reason this efficiently, tackling problems that used to take unimaginable computing power, what new frontiers is it about to unlock for us? In science, in medicine, in technology, the possibilities are just so exciting to think about.